All right, so this lesson is going to be about similarity in right triangles. And we're going to talk about when we take a right triangle and we cut it apart into two smaller triangles, what are some relationships we notice? So first, let me show you what I mean by we cut it apart into two smaller triangles. If we look down here at this bottom example, they've drawn what they call an altitude. So the altitude is this segment, this perpendicular segment that they've drawn to the hypotenuse. So if you want to label that one as the altitude, you can. Notice that when you do that, we're going to cut this triangle into three triangles. And these three triangles are going to be similar triangles. So I need you to make a note of that. And because they're three similar triangles, we know we're going to be able to set some things proportional. Now, unlike when we did the medians that cut the one triangle into four smaller triangles that were similar, if you remember doing that, drawing those mid-segments that connect, sorry, mid-segments, not medians. When we drew those mid-segments, it created four smaller similar triangles. This is going to create triangles kind of on top of each other. So what I'm saying is that they share some sides. So notice, the hypotenuse in triangle 1 becomes part of a leg for each of triangles 2 and 3. So the parts that are proportional, right, the hypotenuse for any of these triangles are going to be proportional to one another. So notice the hypotenuse on triangle 1 is here, but the hypotenuse on triangle 2 is this leg on the left, and the hypotenuse for triangle 3 is the leg on the bottom. Okay, now, so that's the hypotenuse, but remember triangles have a few different sides. We also have the short leg, so I'm going to talk about the short leg on triangle 1. If you try to identify the short leg on triangle 2, it's going to be right here in the middle. So this is the short leg for triangle 2, where the short leg for triangle 3 is over here on the hypotenuse. So notice that all of these things, all of these measurements are coming within the same triangle. All right, that's the short leg for triangle 3. And then the last part that these triangles have is what I call a long leg. So I've got this long leg for triangle 1. Now the long leg for triangle 2 appears to be part of the hypotenuse over here. And then the long leg for triangle 3 is this altitude. So notice that different sides are different quantities for different triangles, which kind of gets a little bit confusing. For example, the hypotenuse on triangle 2 is the same as the long leg for triangle 1. Or the hypotenuse for triangle 1 is made up of the long leg for triangle 2 and the short leg for triangle 3. All right, see how this is kind of all overlapping? So if you need to draw the triangles separately in these problems, that may be helpful for you so that you can see and kind of keep all of them straight. So if we look at what this looks like using a triangle that's already written, let's look at how we can use these proportional relationships. So the first thing I'm going to do is figure out which triangle A and C are both a part of. So if I trace A and C, I realize that that's the long leg of the large triangle over the hypotenuse of the large triangle. Now, A is being used again in another triangle, and I can see that that's the medium triangle. And I know that A, because C is the hypotenuse of the large triangle, A must also be a hypotenuse of another triangle, which it is the hypotenuse of the medium one. Now I need to compare that to the long leg of the medium triangle, which in this case, now that I've traced that out in blue, the long leg is E. Okay, let me erase my marks and let's try the second proportion. So in the second proportion, they start with B and C. Okay, so again, I'm using this large triangle here. That is my short leg and my hypotenuse. And they're telling me that B must also be a hypotenuse because it's on the bottom, right? These are in corresponding spots. So B is the hypotenuse for, let's see, this looks like this small triangle right here. So they're asking me, what is the short leg of that small triangle? And I can see that the short leg of that small triangle is D. All right, so let's look at what this looks like when we go to solve a problem. All right, so I'm going to show you one method in this problem, and then tomorrow I'm going to try to show you a different method in class and see which you prefer and go from there. So In this problem, they're asking us to find the indicated values, which means they're asking me to solve for x, y, and z. Sometimes it may help you to break the triangles apart into separate triangles, but in general, when they ask you to solve for this, we're just going to say we can solve for x first. I'm going to show you tomorrow how you can know for sure that x is going to be an easy variable for you to solve for to begin with. So if I want to set this up, I know I need to solve for x first. So the first thing I'm going to ask myself is, what two triangles is x part of? And I can see that this is part of the medium-sized triangle and the small-sized triangle. So in the medium triangle, I can set up a proportion. I could do x and y, but that's not going to help. I don't want to use two variables, so I'm going to use x and 10, which means I am setting up the short side, or the short leg, over the long leg. And I need to do that in a corresponding way for the small triangle. So I'm going to do the short leg of the small triangle, which is 2, over the long leg of the small triangle, which is x. So I know that this proportion is set up correctly. So like we did in class today, we're going to cross multiply. That's going to give me x squared. X times x is x squared, right? Equals 20. And then to get x by itself, you all know we take the square root. And so far this year, we've just left this as the square root of 20. But remember, we can actually break this down to look a little bit simpler. The square root of 20, if we pull a perfect square number out of it, the only perfect square number that divides into 20 is 4. So I'm going to split this into square root of 4, square root of 5. And I'm doing that because I actually know the square root of 4, and that's 2, which means x is equal to 2 square root 5. So a few things. One, we should always label that on our picture so that we can use that later. And then also I want you to take a note that this is an example of geometric mean or average, right? That's what that word means, no pun intended. Geometric mean is when you have the same variable that's going to cross multiply by itself. So really the definition of geometric mean is to multiply two numbers together and take the square root. So geometric mean is when you multiply two numbers and take the square root. Arithmetic mean, which is the average, that's the one that you've always learned before, is when you add two numbers together and divide by 2. So kind of put that in your notes, and then we'll see maybe where that's going to pop up later on. All right, so that's solving for x, and now we want to go back and solve for our other variables. And we could continue to set up proportions, and I'll show you tomorrow. Like I said, I'm going to show you a different way to kind of think about this problem. But something that's nice about these is these are all right triangles. And if you know two sides of a right triangle, you can always find the third with Pythagorean theorem, which I have a feeling that more of you are probably going to want to do. So for example, if I wanted to solve for y, I could use this small triangle, the medium triangle, and set up Pythagorean theorem for myself. So I could set that up as 10 squared plus 2 square root 5 squared equals y squared and solve that out. All right, or if I wanted to solve for z, I could set up 2 squared plus 2 square root 5 squared equals z squared, and then work that out. Now, some of you may have the question, and so I'll work part of this out for you. How do you do this 2 square root 5 squared? All right, that's the same as, so the 10 squared, I think you know, that's 100. 2 squared is 4, and the square root of 5 squared is the whole number 5, which means that whole thing squared is really 20. All right, equals y squared. And then you could keep going on your own. For the other one, just to kind of say that again, well, I've already said that, it's the same one. 2 squared is going to give you 4. 5 squared is going to give you the whole number 5. So again, that's going to be 20. All right, so that's how you could solve and get y and z. So make sure you have notes taken. Put stars next to anything you want me to spend some more time talking about tomorrow, and then we'll work some problems together.